Good day to all judges of MTE 2024. My name is Dr. Saeed, and on behalf of the team, I'll be presenting our innovative solution, Integrity Assurance Management for Non-Destructive Radiographic Films. NDE or non-destructive examination is the act of evaluating a welded component. The purpose is to locate and determine the size of any discontinuities. If these discontinuities are too large or too often within the weld, it becomes a defect. Defects will compromise the weld overall strength, and in extreme cases, catastrophic failures with loss of property and life can occur. A common example is the gas pipeline explosion that killed 8 people and destroyed 38 homes. Traditional manual inspection is a tedious process that causes production delays, material wastages, and low efficiency. With advances in AI technology, manufacturers look to integrate machine vision solutions to overcome their challenges of operational efficiency and improve quality with security and safety in mind. The current pain points within the weld verification process include: 1. Under the construction stage, you have subjectivity and inconsistency in film interpretation, resulting in low interpretation reliability. The second one is RT duplication during construction stage. This is a very common substandard process that occurs in the welding industry. And lastly, inadequate review and assurance effectiveness due to manual process. During the operation stage, as we know, RT film lasts for 5 years. There are no backups of physical RT film in terms of digitalized RT films. This hinders the process of traceability for revalidation purposes. The solution will provide higher confidence and interpretation based on industrial codes and standards during the welding process. Our solution is a cloud-based AI solution that will perform integrity assurance management. As we all know, the welding process is a manual process. It starts by the welding process, then generation of physical RT films. Then the verification process is a manual process whereby inspectors have to take the RT film, put it behind a light, and manually check for each defect one by one. This is an example of a scanned copy. So our solution starts by fast conversion of the physical RT film into a scanned copy. The scanned copy is later uploaded for all different projects at the same time. After the uploading process, the Integrity Assurance Management System will first automatically perform weld defect detection, weld classification, and sizing accuracy. As you can see in this example here from the previous plain RT film, the model is able to detect different types of defects within the weld profile, then classify the defects using a coloring scheme to match different types of defects that exist in welding industry, and lastly is able to perform a sizing accuracy by automating the process and determining the size of the defect. The current process in the welding industry is a manual process whereby they're using rulers to determine the size of the defect. Our solution is able to automatically calculate the size of the defect and pinpoint directly on which type of defect and the size of the defect in terms of width and length. As we know, we have standards, industrial standards. So based on the type of equipment, the model is able to automatically extract all the defects detected, and based on the size of the defect, it's able to assess if the defect is passed or rejected. With rejection means that the joint has to be re-welded again. Another feature within this integrity assurance management system is the RT duplication or integrity check. As we know, in the welding industry, it's a common substandard process whereby vendors duplicate the RT film. So instead of performing the check in each joint, they use one joint and duplicate for other joints. It's a very common standard process. What is commonly known as the Alibaba in welding industry. So in this solution here, at the example shown here, the model is able to analyze different RT films and check for any duplication within the weld profile. In this example here, we're able to see that the model is able to detect and classify these two films as duplicated RT films. Our solution is a game changer in the industry. After designing the solution, we're able to perform field validation. through a workshop. So we tried to simulate different scenarios of reshooting at the same joint and creating manual overlap scenarios. So our model is able to detect all overlap scenarios and all joints that have been reshoot at the same time, and the RT film has been labeled with a different name. In terms of result achievement, we're able to successfully authenticate all the tested RT films, and our solution is currently released to marketing. This solution is a game changer. Why? Because it provides different functionalities. No solution in the industry exists that can provide all these functionalities. Number one is soft copy RT storage through the cloud. Then we're able to perform weld defect detection, and we're able to classify the detected type of defect and perform a sizing accuracy. Then we perform an API check based on the equipment standards. And lastly, we're able to perform the radiographic duplication check for all RT films. Our intellectual properties currently include one international patent and one Malaysian patent. And in terms of commercial potential in industrial partners, this solution has significant commercial values in terms of licensing and joint ventures with welding contractors due to scalability of welding operations to various equipments like piping, pipeline vessels, tanks, static tank, etc. Among our industrial partners are Bumitec, Wasabi, BV, and industrial partners also include Petronas Chemicals, Petronas Charigali, and Petronas Gas Berhad. In terms of sustainable goal development, this solution, the welding solution, addresses SDG goal number 9, which falls under industry, innovation, and infrastructure. As we know, the welding industry is a significant global industry, and together with welding as an enabling technology, it plays a critical role in the world's ability to cope with these pressures and challenges and drive significant progress. Thank you all to all judges of MTE for listening to our solution and presenting our solution. Thank you all.